Hello students, welcome back to Future Foundation. Students, in last class of vector and 3D, we have started 3-dimension geometry. So let's continue 3D. Now let us come to direction ratios. What are direction ratios? So make heading direction ratios or DRs. So what are the direction ratios? Let us write in this. If DCs or direction cosines are element, then DRs are LK, MK and NK, where K is any scalar, right? That is what I am saying. Any three numbers can be direction ratios or DRs if they are proportional to DCs, right? That is if A, B, C are direction ratios, then LA L upon A is equal to M upon B is equal to N upon C is true, right? Because element are the direction cosines, and what are direction ratios? Direction ratios are any numbers which are in the same ratio with direction cosines, right? So if I am defining ABC direction ratios of any vector, then L upon A is equal to M upon B is equal to N upon C. Must hold. So if this holds, then this can be written as root over L square plus M square plus N square by root over A square plus B square plus C square, right? So this thing is 1. So L is A upon root over A square plus B square plus C square. Means direction cosines in terms of direction ratios is this. Similarly, M is equal to P upon root over A square plus B square plus C square, and N is equal to C upon root over A square plus B square plus C square, right? Let us write an important point. Direction cosines for any vector are unique, but DRs are infinite. Okay, this can be understood. This thing can be understood by taking an example. Let's say DCs for any vector are 1 by root 3, 1 by root 3, 1 by root 3. Okay, so ABC corresponding to these DCs can be any three numbers which are in the same ratio. That is, so DRs can be defined as 2 by root 3, 2 by root 3, 2 by root 3, or 4 by root 3, 4 by root 3, 4 by root 3, or 1 by 3 root 3, 1 by 3 root 3, 1 by 3 root 3, right? And so on. Because K can be any real number, right? K can be any real number. So that's why I'm saying that DRs are infinite. Okay. Okay, now let us take a question. Let R vector is equal to 3i cap minus 4j cap plus k cap. Find the angle for y-axis, right? Means we have to find the angle which a vector r is making with y-axis, right? So first of all, we have to find cos alpha. Okay, so r vector upon mod of r vector is 3 I upon root over mod of r vector is nothing but 3 square plus minus 4 square plus 1 square minus 4j on root over 3 square plus minus 4 square plus 1 square plus k cap on root over 3 square plus minus 4 square plus 1 square. So this is r cap is equal to 3 upon root over 38 root over 26 I cap minus 4j upon root over 26 plus k cap upon root over 26. So we have to find the angle with y-axis, or you can say cos gamma cos beta is minus 4 upon root over 26, where beta is the angle made by r vector with y-axis. Okay, or beta is equal to cos inverse of minus 4 root over 26, or you can say beta is equal to pi minus cos inverse 4 by root over 26, right? Question is, if p vector is equal to 4 I cap minus 2j cap plus 8k cap, then first ABC means you have to find the direction ratios, second r cap, and third find angle of r vector with x-axis. Okay, again very simple question. You need to find ABC direction ratios. So if I find the direction cosine, so direction cosine is nothing but 4 upon root over v vector mod of v vector. So this is A, this is B, and this is C. Simple. So coefficient of ijk is nothing but ABC. So this can be 4 minus 2 8, or this can be 2 minus 1 4. Okay, both are correct, or more than 2 can be written, right? And r cap means v cap. Okay, not r cap, it is v cap. So v cap is mod v vector upon mod of p vector. So 4 I cap minus 2j cap plus 8k cap on root over 84 root over 16 plus minus 2 whole square, that is 4 plus 4 plus 64. So 4I upon root over 84 minus 2j upon root over 84 plus 8k upon root over 84, right? And now third one, the angle of r vector, not r vector, it is v vector with x-axis. So we need to find cos alpha, which is 4 upon root over 84, or alpha is equal to cos inverse 4 upon root over 84. Next question, a line makes an angle of 45 degree with x-axis, 60 degree with y-axis. Find angle with z-axis. Right? So I have to find the angle which is a line making with y-axis with z-axis. So from cos square alpha plus cos square beta plus cos square gamma is equal to 1. I can get this gamma. So cos square alpha is 45 degree plus cos square beta is 60 degree plus cos square gamma is equal to 1. So this is 1 by 2 plus 1 by 4 plus cos square gamma is equal to 1. So cos square gamma is equal to 1 minus 1 by 2 plus 1 by 4, that is 3 by 4. So cos square gamma is 1 by 4, or cos gamma is equal to plus minus 1 by 2, or gamma can be, if cos gamma is 1 by 2, then gamma is 60 degree, and if cos gamma is minus 1 by 2, then gamma is 120 degree. So how can be two values for gamma possible? So let us understand this thing by drawing a figure. Suppose this is a vector OP, right? This is x, this is y, and this is z. So mm, if this is 45 degree, this is 60 degree. So this angle is 60 if z-axis is making with the OP vector. So how can this 120 be possible? So this OP, if I am taking this OP in uh, above the above yx, so I can make this OP below yx, right? Below yx, but as x and y are positive in that case also, so angle will be 45 degree and 60 degree. But if this OP will be below below xy plane, then with positive direction of z axis, this OP will make pi minus 60 na. So pi minus 60 is nothing but 120 degree. Okay, so this I'm saying, if this thing happens, this OP is going down, putting this thing by dashed line, this P dash. This OP dash is below xy plane. So then that angle will become 120 degree, right? Now let's come to next question. Question is, if alpha minus beta is equal to 90 degree, find gamma. Okay, so we have to find the gamma angle, or angle which OP factor is making with z axis. So alpha becomes 90 plus beta, So cos alpha is equal to minus sine beta, right? So from cos square alpha plus cos square beta plus cos square gamma is equal to 1, I can write sine square beta plus cos square beta already plus cos square gamma is equal to 1. So 1 plus cos square gamma is equal to 1, or cos square gamma is equal to 0, or cos gamma is equal to 0, or gamma is equal to 90 degree. Means the vector is making with z axis angle is 90 degree. Okay, now let's come to next question. A line makes equal angle theta with x-axis and z-axis, and beta with y-axis, and sine square beta is equal to 3 sine square theta. Find cos square theta, right? So I have to find that angle theta. In fact, we have to find cos square theta. So from cos square alpha plus cos square beta plus cos square gamma is equal to 1. As alpha and gamma are the same and they are equal to theta, so I can write cos square theta plus cos square beta plus cos square theta is equal to 1, right? And sine square beta is equal to 3 sine square theta. So sine square beta should be in the picture. So this is 2 cos square theta plus cos square beta can be written as 1 minus sine square beta is equal to 1. So 1 cancel out, and 2 sine square theta minus sine square beta. In place of sine square beta I can write 3 sine square theta. 3 sine square theta is equal to 0. Sorry, this is 2 cos square theta, right? And 2 cos square theta minus 3 times 1 minus cos square theta is equal to 0. So this will become 5 cos square theta minus 3 is equal to 0, right? So cos square theta will become 3 by 5. This is the final answer. Okay, now let's move to next question. Question is DRs of two lines are 6 minus 4 minus 4 and minus 6 to 1. Find DRs of line perpendicular to both of them, right? So we have to find the DRs of a line which is perpendicular to both these lines, right? So what I'm seeing, say these are two lines, and I have to find the equation, the DRs of the line which is perpendicular to both of these lines, right? So how can I find the DRs? So let's say if corresponding to these two DRs, two lines are presented as r vector is equal to a vector plus lambda times P vector, that is 6 4 minus 4, right? And second line is B vector plus mu times minus 6 2 comma minus 1, because TRs of two lines are this coefficient of lambda and coefficient of mu. Because if any line or any vector has some DRs, then it means that line is parallel to the vector having those DRs, right? The thing is that, so if I want a line which is perpendicular to both these lines, then how can I find that thing? Using cross product. So for DRs having a line perpendicular to the above lines, we will use product, right? So for DRs I am writing this determinant I j k 4 minus 4 minus 6 2 1. So I kept times 4 plus 8 minus j kept times 6 minus 6 4 is 24 plus k kept times 12 plus 6 4 is 24. So this is 12 I cap plus 18 j cap plus 36 k cap, or DRs be 12 18 36 or 2 3 6. Okay, both are correct. You can stop at this point, 12 18 and 36. I am writing in list down. Okay, also there is another method exist. Say this is so I'm assuming that DRs be ABC. Then according to question, if lines are perpendicular, then the sum of product of DRs must be 0. That is 6A plus 4B minus 4C is equal to 0, and minus 6A plus 2B plus C is equal to 0. Because in question it is given that line having DRs ABC is perpendicular to the line having DRs as 6, 4 and minus 4 and minus 6, 2 and 1. So in that case, sum of product of DRs must be 0. So now using cross multiplication rule, A upon 4 plus 8 is equal to B upon 26 minus 6 is equal to C upon 12 plus 24. Right? I'm using, or I have used this cross multiplication rule. So 6 upon 4 to 1 minus of minus 4 into 2, right, is equal to B upon minus 4. This is 24. So minus 4 into minus 6 minus 6 into 1 is equal to C upon 6 into 2 minus of minus 6 into 4, which is 20, right? So from here A is to B is to C is nothing but 12 is to 18 is to 36, or A B C can be 236, right? 12, 18 and 36 is also correct. Now let us come to next heading, which is unit cube. So make heading unit cube. So in this we will find the angle between the body diagonals of a cube. So let us make a cube having each edge or having each side as 1 unit. Let's see, this point is P. If each side is 1 unit, so coordinates of P will be 1, 1, 1. Coordinates of origin is 0, 0, 0. Let's say xy plane. In xy plane, it is P here. Say M is here, L is here, A is here, C is here, P is here, and D is here. Okay, so coordinates of M will be 1, 0, 0. A will be having A coordinates of A are 0, 0, 1. Coordinates of C are 0, 1, 0. Coordinates of B are 1, 1, 0. Coordinates of D are 1, 0, 1. Coordinates of L will be 0, 1, 1. Okay, now we have to find the angle between the body diagonals or simply diagonals. If, for example, they are both for body diagonals and between any two angle will be same. So for example, I am interested in finding the angle between OP and LM. P and LM, right? So here I am taking OP as OP vector and LM as LM vector, right? Now for this I am making a table. Column 1 body diagonal, column 2 TRs and column 3 TCs. First body diagonal is OP, second is LM, third is CD, fourth is AB. Direction ratios of OP or OP vector. Direction ratios for OP vector are C. Direction ratios of any vector. Having direction ratios of any vector can be found out by taking the difference of the position vector, right, of P and O or corresponding endpoints. So 1 minus 0, that is 1, 1, 1. Direction ratios of LM. So minus 1, 0, minus 1, 1, 1. Direction ratios of CD, 1, minus 1, 1. Direction ratios of AB, minus 1, and 1. Okay, so if DRs are known, then DCs can be found by using the concept A upon root over A square plus B square plus C square. So this will be minus 1 by root 3, 1 by root 3, 1 by root 3. Similarly, sorry, this is root 3. This is minus 1 by root 3, 1 by root 3, 1 by root 3. This is 1 by root 3, minus 1 by root 3, 1 by root 3. And this is minus 1 by root 3, minus 1 by root 3, 1 by root 3. Right? Now, how can we found theta or angle between OP and LM? So, and also I am considering the acute angle. So, cos theta can be found out by using mod of L1 L2 plus M1 M2 plus N1 N2, where theta is an acute angle and L i's, M i's, N i's are DC's of OP and LM vector, right? So cos theta is equal to mod of 1 by root 3 into minus 1 by root 3 plus 1 by root 3 into 1 by root 3 plus 1 by root 3 into 1 by root 3, right? This thing will be cancelled and this is 1 by 3, which is cos theta. Or theta will be cos inverse 1 by 3. Right, this is the angle, and which is very important. Okay, now let us take another question. If DCs of the line are LMN, right, and this line intersects all diagonals or all body diagonals of a unit cube, then prove that sigma is sigma cos square alpha is equal to 4 by 3, where alpha, beta, gamma and delta are the angles made by the line with the diagonals. Okay, that line is making angle alpha with diagonal, then cos alpha will be L into 1 by root 3 plus m into 1 by root 3 plus n into 1 by root 3, right? Okay, first body diagonal is I'm taking the OP vector, right? So with the OP vector, that line is making an angle alpha. So again using cos theta is equal to mod of L1 L2 plus M1 M2 plus N2 N1 N2. I'm writing this one, right? Similarly, cos beta is equal to what? Minus L by root 3 plus M by root 3 plus N by root 3, right? Gamma is L by root 3 minus M by root 3 plus N by root 3 and cos delta is equal to L by root 3 plus M by root 3 minus N by root 3, right? So therefore sigma cos square alpha is nothing but cos square alpha plus cos square beta plus cos square gamma plus cos square delta. So I have cos alpha, cos beta, cos gamma and cos delta. So after putting in this equation I will get what? 4 upon 3 L square plus M square plus N square. Okay, you can expand the identity. So from here I can say summation cos square alpha is 4 by 3, which is required, proof. Okay, so students, for today's class this was all about. Let's meet in next class. Till then, bye bye, take care.